Hello everyone. This video will be on the 3.13 section of the IBAA curriculum. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes this section is, you can multiply two vectors to get a scalar. So in the last video, we talked about the vector addition and multiplication of a vector and a scalar. In this video, we will talk about a multiplication of two vectors and what we get from it. The type of product we're going to talk about is called a scalar product. And you may deduce from the name of the product, yes, the product of two vectors will be a scalar value, or aka just a number. Well, how do we do it? Well, the process itself is extremely simple. We just need to multiply the matching components together and find the sum of them. Let's do a quick example. When u equals 1, 0, and 3, and v equals -2, 1, and -3. Well, we can use the formula to do where we'll go like u v equals v1 times w1. So the first number is 1 times -2 plus 0 times 1 plus 3 times -3. Well, 1 times -2 is -2, 0 times 1 is 0, and 3 times -3 is -9. Therefore, we get -11. There is another method to do it, if you don't know the exact details of each vector, we can use the second formula. The second formula uses the magnitude of each vector and the cos theta. How weird, right? Well, here the theta yields a great insight on what we're doing. Let's go back to the answer from the example that we've just solved. What does -11 mean? Why should it be that? Can't it be like +1, -1, or 500? Why does it have to be -11? We can find the meaning of the scalar product in the next formula. Since the magnitudes are just numbers, that doesn't matter too much, but we should focus on the cos theta part. The theta is the angle between two vectors. And we can use the connection here to make this statement that scalar product tells us about the angle between two vectors. And that is the main purpose of this product. Let's now focus on the angle part, because there are some special numbers that you may get for your cos theta. Let's try one with the scalar product of 2, -5, and -5 and -2. Well, we'll use the same example. So this will be 2 times -5 plus -5 times -2. Well, this is -10 plus +10, so we get 0. Well, what does that mean? And we can tell from the coordinate planes that the two vectors are actually perpendicular to each other. 2, -5, it'll probably something be like that. And -5 and -2 will something be like that. And we can see that they're perpendicular to each other. Do you get what we're trying to do here? When the scalar product of two vectors is 0, then the vectors are perpendicular. We can tell from the fact that cos of pi/2, where pi/2 is a right angle, cos pi/2 is 0. And that's why the perpendicular vectors will always produce a scalar product of 0. Let's try another example. Let's try to do 2, 3 times a 4, -4, and 6. Okay. Well, the scalar product is 2 times 4, which is 8, plus 3 times 16, so 18, so it's 26. Well, what is this value? Well, we can use the angle between the vectors formula to find the cos theta. Let's divide 26 by the magnitude of each vector. The magnitude of the first vector should be 4 plus 9, so 13, and 16 plus 36, 52. So we can conclude that the angle between two vectors is 26 over square root of 13 times square root of 52. Well, the denominator now becomes square root of 676, which is the same as 26. So we get 1. Well, when is cos theta 1? When theta equals 0. So we can conclude that when scalar product of two vectors is equal to the product of the magnitude of each vector, or aka the cos theta is 1, the vectors are parallel to each other. You can see that by when we draw our vectors on the coordinate plane. Maybe this is my first vector, and my second vector could be something like that. So we can see that they're parallel to each other. And this is similarly true when the v dot w is a negative of magnitude of the v times magnitude of the magnitude of w. So in this case, if v dot w is equal to negative of v, magnitude of v and magnitude of w, this case is also parallel. However, the cos theta will be negative 1. So theta is positive pi. So then we can conclude, if they're pi, the angles are pi, then they're parallel. They're also parallel, but opposite directions. Right, let's finish our video with the question as well. Let's say that we have a vector of A where it's 2, 1, 3, and a B where the components are -2, 3, and k. Okay, the first question is, if A dot B is 2, then what is the value of k? And once you solve that, then we can answer the second question. Then what is the angle between A and B? Find the angle in radian to 3 sigpics. The answer, again, perhaps someone in the comment could answer. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.